training missions. For some of you, they will be a breeze. For others, they will be hard and new. Either way, just stick with it, because at the very end, you'll have the chance to compete with students around the globe to show off your coding and gaming skills.
Also, be sure to check the different videos and tutorials that pop up throughout the robot training lessons. It's our hope that you leave this challenge with a better understanding of what computer science is and how it's used in real life at Amazon.
But of course, our main goal is for you to have fun and learn something new, so you can be the next Amazon Future Engineer Scholarship winner. Good luck. May the fastest robots win.
Happy coding!
Okay, so after playing the intro video, you can just click on the next activity and it shows you getting started.
Welcome to the Amazon Cyber Robotics Challenge.
Hey Charles, let's make
My
this
name
full
is
screen.
Hercules, and I'm an Amazon Fulfillment Center drive
Okay, you want, go full screen?
Yes,
Yep.
please.
There you go.
unit.
That's better.
There are many types of robots at the Fulfillment Center. Not to brag, but I'm the most important one. Today, I will be
Thank you,
showing
Jen.
you how to program me. First, let's get our bearings. Here I am in the Amazon Fulfillment Center's training area, and this window pane is called the simulation screen. Your goal is to get me to the yellow target. Can't see me or the target? Scroll your mouse or touchpad to tilt and zoom. Right-click anywhere and drag the cursor left or right to rotate. On the left is the code editing area, where you write the instructions that tell me what to do. Writing code is easy. Just snap blocks together. Click the play button to make me execute the instructions you gave me. You can grab additional blocks from the library. I'm a robot, so I will always do as instructed. If it's not exactly as you planned, don't blame me. Fix your instructions and run the code again. Right-click blocks to bring up a useful action menu. The duplicate option, for example, can be used when you want to give me the same instruction again. I will not execute blocks that are grayed out. I will ignore them. Click here to return me to the starting point. Want to reset the whole mission, including your code? Click this button. The reset button also replays the mission tour. Need help? You can find useful tips here. Bye for now.
Okay. Now, full screen. And next activity. So we're starting our first mission.
I still haven't got an account.
Okay, I guess what we'll have to do is after our meeting, we'll have to work with setting you up with an account or seeing how we can try to get you in. I'm not sure why it wouldn't. I can check the link right now. But I'm
I
logged
have
in.
screen.
What do you end up getting?
I can't sign in. It's just saying it will give it to my email, to my mom's email, but it's not giving it.
Oh, you know what it is? Okay, so I know what it is. So Amazon Coder Z accounts require parental permission if you're under 13. So if you put in your age, your date, and it computes that you're under 13, it's going to require a parent to sign off on the permission to create the account. So it's going to probably ask you for parental information, send an email to them, and then they're going to have to do something on their end to confirm that it's okay.
Okay.
So it's an extra step. But as you can see, once you get in, if you want to just watch along, we're not going to go through a lot of the project, but we're going to get just a few steps in. And then you can play around at your own leisure, and then you'll be able to catch up. Okay? All right, so level 1 are missions to program the robot to drive to the yellow target. So we have a stop, we have to drive 1 step. Okay, and we want to run the code. Bingo. So This is a lot like Scratch. Clicking blocks, you're moving a sprite, but instead of actually moving just a sprite on screen, you're driving a 300-pound robot. So there you go. You start with a toy and you end up with a tool. Next, it'll be a 3,000-pound robot. Look at that, 200,000 robots they have. Okay. So we got blocks for movement, data. Okay, so we drive one step. And I can drive another step. And is this going to do that? Okay, I get you.
I just can't believe the robot was talking itself.
So that'll tell it to start, move one step in the direction you want, and move another step, and we can run. All right. Okay. All right, so we want to move from here to there. So we need to move.
Can you change what from bird eye view?
Okay, do we have some questions in chat, Tim? All right. All right. One, two, three. Is everybody following on so far?
Yeah, so we got one question, Charles. Can we change from bird's eye view?
Okay. All right. Let's see how we change them. I think it, let's see. We'll see how it changes.
I still can't log in because I'm using a fake one.
Okay. You might want to see if you can get your mom to set up an account using her birthday.
I am using it.
Okay. And it should allow you to create an account.
Because I set in my age of 15 just as fake so I can log in, but it says login at the bottom, but I tapped it but it didn't log me in.
Oh, I'm not sure. But since we're in the middle of the class, we'll have to continue and we'll have to try to get you logged in later and see if we can do it. But as you can see, it gives you enough information in order to do the challenge, offline as well. Okay. So I guess you can just kind of watch, see how things are done. And then when you get logged in, you can run through the steps. Okay. Is that good?
Yeah.
All right. We got a repeat loop. There's the drive strip. Okay. So drive in. All right. Yep. Iterations. Okay. All right, so repeat 4 times, drive 1 step. Yep. Okay, you guys want to change from bird's eye view. Okay, so we're here. I think the view is controlled during the mission.
Yeah, we could try it on the next one here, the bird's eye view.
Okay. All right. So next step here. Okay, that makes it easy. So you don't have to worry about the orientation of the robot. You just tell it where to go.
So you actually can differentiate from bird's eye view.
We're gonna make it go that way, and then we gotta go that way.
What will happen if you drag it?
Make it go 4 times that way. Okay. Sounds good.
Let's try to switch the bird's eye view. Bob's also saying, I think you missed mission 4, by the way.
Oh, really?
But that's okay. Let's keep moving here. There's a, I think there's like this settings option in the top right there. The menu in top right of the simulation.
All right, here.
Nope, down one.
Or this one. Heads up display.
Yep. But I don't think they give us that option. So
Doesn't look like they give us like a flat view. It's the top view.
yep, just the top view.
Okay.
Gigantic tree.
Okay, so I'm gonna go back to Learning Center, mission 4. Looks like I did it.
All right.
Yeah, we did this. That was the one where we just programmed the first loop. I'm gonna go back to, now let's see where I go back to mission control. There we go. Back to Learning Center. All right, so we did through 5, 6. We'll get up to the ERC quiz. Okay. All right. So that's our, oh, that's no problem. So,
It looks like we can right click and hold the simulation to change the perspective. And you can also use either 2 fingers or the zoom wheel to, or the scroll wheel to zoom in and out.
okay, I'll give that a shot here in just a second. When is that effective? That's effective like when you're running the simulation?
I believe it's before, because I don't think that they give you that option while it's running. Maybe they do. It's worth a shot.
Okay, so right click. Wheel.
Yeah, right click and drag. There you go.
Oh, look at that. Oh, that's kind of cool. Now we get it. That even looks even cooler. Okay, so do we want to go all the way down? What do you guys want to look at? Like this? Let's see it like rolling around. Oops, I think I messed up. I went too far. Okay. I need to go 3. 3. And 3. Oh, it starts from where it is. All right, hold on. All right, so where'd my robot go?
Yeah, try reset simulation.
Reset. There you go. All right, there you go. Thanks, Bill. That's better. That's kind of cool. I think this is more visual than Scratch in a lot of ways. Should we take a pause here and ask anybody got questions, or how are we doing so far?
Not seeing any questions in the chat here. I think we're good to go.
Okay. It's just 3 instruction blocks. Okay.
Nathan's asking, are we going to learn any type code?
I think that's in the later simulation. Type code. That's a good question. I don't think we can do. All right, so I got a question on this one. I'm not sure about this one. How do you get around that? In 3 blocks? Okay.
Apparently you can do it with only 3 blocks. So.
Does the robot drive through these things?
You need a control, or you need the repeat thing, and then you do 2 of
Oh,
the
yeah.
steps.
Okay.
It's like a staircase.
You're right. That makes sense.
Yeah.
In the repeat, we'll do 2 movement blocks. Move this way, move this way. Then move this way, move this way. Move this way. Okay, yep. Well, there's 1, there's 2, there's 2. Yeah, that works. Yay. That's not that long ago. So he built the robot 3 years ago, and there's 200,000 of them. Think about that. Let's see. Okay. And move over one. Okay, so we're gonna do a zigzag, right?
I'm pretty sure. Hi. Again.
You could do it like that. And make it a move down. All right, so that's our challenge. How many times we got to do this? Okay, so we're going to repeat this. Okay. And then, yep, okay. So 3 times. Could do it 4. Then we just move forward.
Why is that called a mission?
It goes down to there. Actually, let's do it 3 times. So we're here. Then we do a loop down, across, down, across, down, across. Yep, okay.
This
So
one is extremely
I'm creating a
difficult.
loop at the top that'll make it move like this. Then I just move down 3 times. And the reason I stop here is because I'm going to create a loop that'll move down, across, down, across, down, across. So I'm doing 3 loops total. Oops. Okay, so it'll go up, 1, 2, 3, 4. 1, 2. Oh, I only need to do 2 times. 1, 2. Then from here, 1, 2, 3. Do we think it'll work?
Yeah, let's give it a shot.
Like crossword puzzles, right, Tim?
Yeah, a little bit. I think what we could do here is probably go just 3 times on the first loop and then over 1.
Can Can we?
and then
Is it
down.
possible if we can test it and see what happens if you crash into one of those cones?
Oops. Can I do that?
All right. Miriam was asking if we could crash into the cones. Yeah, let's keep these questions to the chat, please.
I did. Nobody seems to notice.
Oh, I got you. I got you. That's why I'm talking to Charles right now.
All right, we're gonna crash into some
Yeah.
cones now. We're gonna make a mistake and see what it does. Because you know the engineers just like, what if you program the robot wrong and it runs
Really
into
what-
something? Okay, so just to play with that, I'll repeat the mission. All right, so that's a delete, that's a delete. Okay, so by doing this repeat 4 times, I'm going to crash into that cone right there. Okay.
That's hilarious. You know.
All right. So there we go. All right.
What happened?
My score.
Messing around with
That
all
was-
of those.
All right, let's keep
Okay, the
keep
quiz.
moving here.
Okay. So repeat 4 times. Move this way. Drive 1 step that way. Boom. Let's see. This one. Repeat 4 times. Move this way. Move this way. Then this way. This way. This way. This way. This way. This way. So, well, we know. Let's see. This would move it 1, 2, 3, 4. Oh, it's just doing 1. Well, the first one's not going to get there because it's going to run right into that cone. Okay, so what do people think in chat? Which one is it? First, second, third, or fourth scenario? I think it's this one.
All right. Nathan and Campbell both think it's the first one. All right.
So following programs will get the robot to the same place in the training center floor. Click all that apply. Okay. So drive it 2 forward, 1 back, 2 forward, 2 forward, 1 back, 2 forward. So basically, it's an equivalent of 1.
Nathan thinks it's first and second in this one.
Back 1 step, 2 forward. Then we go left, right, left, left. So it end up there.
All right. Miriam thinks it's number 2.
So number 2 is the one that will not get to the same spot.
I did not say that. I was making a joke about it.
Yeah, that looks. These 2 look the same. So now let's look at this one.
Yeah, you have to pick 2.
I was saying in order of the errors. Number 1, crash into the barriers, and number 2, find yourself back where you started.
I think it's those 2 because they both get it to there. This one will get it to the square next to it.
Yeah, Nathan's pretty adamant. It's 1 and 2.
Good job. Why is the program showing the easiest to change in case the target system changes? Because we only have to change the number in the repeat box. Program corollary. We're lazy and we don't like to have to write more code than we need to write. Besides, it's simpler and easier to fix later, right, Tim?
Yep. Hey, Miriam, could you go ahead and mute, please?
Robot training missions. You always get to code the robots to move different distances. There are corresponding ways to find them in the long term. Which of the following terms is easiest to change for this? Well, this is kind of like the other question. You don't want to muck around with that if you could just have one step. You always try to take advantage of loops to make it easier to write the code. All right. So how's everybody doing? Are we having a good time? You liking this?
Everything's going super slow.
Okay. Before I'm going to pause this. Okay. No, I want to pause it. Okay, it's paused. Okay. So, now it's starting.
Before we begin, let's learn a little about how customer orders are fulfilled at Amazon.
It was not 100
Welcome
questions.
to one of Amazon's fulfillment centers. Inside these massive centers, Amazon uses a fleet of robots named Hercules to help get their customers their items, maybe even their friend's birthday present, fast. At the fulfillment center, products are from all over the world. Rather than putting them on shelves organized A to Z, they are stored in movable, tall yellow shelves called pods in the warehouse. Instead of walking to the different pods to pick up items, robots do the work for us. For example, if I buy Abakir headphones for his birthday on Amazon.com, a robot comes to pick up the pod where the headphones are stored. Then, the robot brings the pod to another assigned station where an Amazon associate can pick it off the pod and place it in a tote for shipping. Voila! The order is fulfilled and my birthday present is on the way. This delicate dance of thousands of robots and humans working together is made possible by computer science. Now it's your turn to learn more about how this complex process takes place so seamlessly. Good luck on this challenge and happy coding!
All right. I don't know about anybody else, but that warehouse looks pretty rad. So, next activity. So it'll lift 1,200 pounds, 1,250. And it's a 300-pound robot. Amazing. Okay. Okay. All right. So basically, we're going to have an extra code here. There's a lift up and a lift down. Movement category. All right. So we are going to obviously move forward a couple steps. We're going to lift up. And then we are going to move that way. 2 steps. So boom, boom, lift, come up, lift down. Okay. All right. Everybody think it's going to work?
Let's give it a shot.
Got some kind of freaky 6-day. Cool. All right. Mission 10. All right. So now the good thing is we remember to get there, I can drive under other pods. So I can do a loop. Right. I'm going to want to move up to here. So we'll drive it forward. Okay, that'll get it to there. We don't really need a loop for this. We just move. Shall we see what happens if we crash into the other simulation?
Sure.
Why not? Let's
Why
do
not?
that. Let's see, because I want to see what happens if you okay, we lift the stack. All right, this will be fun. Let's see what this looks like. Oops, I missed. All right, let's fix this again. So it just moves the stack. I was just wondering if it was gonna stuff was gonna be smashing everywhere. All right. All right, so we actually got to move. Actually, we want to move down. I'm going to move this up so I got a little more space, and then I'm going to move over. And that's 3. So let's make it work. I forgot to do the lift down. I got it to the target, but I didn't lift it down. No, not that one. Oops, what did I do? Move one step. There we go. There we go. Cool beans. There's a basketball within the time limit. Let's see. So this one's the closest one with a basketball, right? Okay. So what we're going to want to do is move 3, go get that one. So we're moving up there. Now we're gonna lift it. And then we're gonna move down. And we're gonna move 3 over. And do this. And do that way. And move it. There you go. So up, lift, down, cross, down. Okay. So far, so good? Any questions so far?
I'm not seeing any in the chat.
Okay. All right, so what are they asking us to do now? Okay, they want this blue thing. Which looks like it's this thing here. I might say that that looks the same, but I'm not sure if it is. That one looks correct. Move over 1. Move over 6. And just move 1. Okay, so it's going to go there, and then a lift. Okay. And then we're going to come so I'm driving here, coming up here, lifting it. I'm going to move it here, come down here, move it over here, and then be done. 1, 2, 3, 4 steps. And the wheel is down. And over 1. All right, still look good? Everybody think it'll work?
Give it a shot.
Underneath the stuff. Yes, got it. Whee. Oh, what I didn't like it? That's interesting. Oh, I guess it wants me to use this one. Well, what did it not like?
You have to complete it in a set amount of time. So 27 seconds or less.
All right. So do we think we could do it quicker? Is that from the time I program it or the movement time? Let's see what the movement time looks like.
Yeah, it's the movement time.
I think it's slower when you lift up and carrying all the load.
Oh, that's a good point.
Wow.
You were like milliseconds off.
So what do you think it wants different? Okay, let me try again. Okay, I got to think about it if there's another way to do it. Okay, I got an idea. Let's see. Let's just, instead of this, I got a better idea. Let's instead do this. So I'm going to just move 6, drive 1 step, lift, drive 1 step. So it's not turning after lifting. Let's see if doing the steps in a different order makes a difference. It's faster. Bingo. So even though it moved pretty much the same, by making it move in a free area, it must have gone a little quicker. And besides, I think I reduced by 1 turn, and the turn takes time. There you go. See what they want us to do. Okay, so they want us to move a pod out of the way.
I think that they want you to move this thing out of the way, the empty one, and then get the one that has the stuff.
Oh, okay. So I gotta do more. All right. So I moved the pod. Let's reset the simulation. So that's only the first part of it. Okay. So we're gonna move that, drop that down. Then they want to go get that thing. And I move. Ah, there you go. Actually, for 2 movements, I could just do 2 drive, 2 steps. Cheating. All right, what do we think? Now this we don't need. So lift up, move a step, drop down. Then I'm going to move up, 1, 2, 3. I'm going to move over a couple, lift up, and I need to go over, down, over, down. I need to do that twice, and lift down. You think it's going to work? Give it a shot.
Let's do it.
All right, okay. They want me to do it quicker. So, all right, so let's see how we want to do it. I have an idea. Okay. So to make it quicker, I'm going to go in the direction I'm going to make this a loop. Okay, so now I'm there. All right, hold on. Come on. So I'm going to move up 3, drop it there. I'm going to move down 1 step. Okay, is it smart enough to let me drop a block on there and change it? Yeah, okay, good. And just make the other one go excellent. Okay, so lift down, move down. We're going to move over twice. Moving will be, oops, I can take this one off. So we're going to move over twice, lift up. Now we're going to repeat 2 times. Okay, so let's see what we're doing. So what we're going to do is we're going to lift it up, put this up here. Now I'm closer to my objective. I will then drop it. So lift up, move 3 spaces up, put it down, move down 1 step, move over 2 steps, lift up, move back 2 steps, move down 2 steps, drop down. All right, see if this thing works. Bingo. Did you get this far before, Bob? You did? Okay.
Mine, let's see, I got it within 3 seconds, 3.25 seconds faster. You know, I had that much time left over
Oh, wow.
because I moved my original pod over to the right 1 step and dropped it
Oh, and then move this
and
1
then
step.
moved. Yeah, so you could, you know,
You can optimize it. I guess the point is there isn't just one solution, just like in real programming. You could do this any number of ways, and some ways
and
are
it's
going to
all
be a
about
little bit
speed.
more efficient than others.
Right, right, exactly. And that's the whole idea, is to make it so it's much faster. Time is money.
Time is money. Oh no. Okay, so what are we on? This time the pod you need is really inaccessible. Get the pod with the order to the target before the clock hits 00. Okay, so we got 37 seconds.
There's no way that you get out of this without moving one of those empty pods.
So which one's the best way to do this? All right.
Charles, quick time check. We got about 10 more minutes.
Okay. All right. So this will be our last mission, and then we'll let kids keep going and playing with this. So, what would be the best? It seems to me like between here and there, the most direct one to move would be this one. But where would you move it? You'd move it. Let's see, 37 seconds. So you'd have to you can come up here, pick this up, move it to there, then come zooming down. It's a lot of steps. So how would you do it quickly? And it's blocked all the way up. So you don't want to probably go any further than going up. I go here. One or the other. I'd say it's one of those two would be the best choice. I'll start with moving this one to like there.
Would it be faster to go straight across with that? So all the way to the left with the empty one?
Like pick this one, go
All the way to the left?
all the way left. You still got to do a
Drop it.
zigzag with the pod to get around it though. If you move this one, you come over here, get this one, move it down, then go straight up, get this one, come down through the opening. Yeah, no matter what. Okay, so I'm going to try it this way, sir. We'll see how this timing looks. So, so we'll do control flow. Repeat. 1, 2, 3. 2, 3, 4, 5. Move 5 up. And lift up. Movement. Actually, I don't need a loop. I know what I'm doing. So I zoom up here, grab this one, and put it there. Okay. Now I'm here, and I'm going to go across 1, 2, 3. Three, move, and we're going to do a lift, and then we're going to do 1, 2, 3, 4. Do 4, and then 3, and that's it. Wait. Okay. All right. So we'll just see it. We'll just let it run from there. Okay. Lifting the stack. All right. Oops. I have to move down. I have to drive down a step before I grab it. How's our time? We got 5 minutes. Okay, we should be almost right there. All right, this is our last one. Okay. There we go. Uh-oh. Well, I didn't do it in time. All right. So, did anybody solve this one? Bob says no, he didn't solve it.
I've been trying to map out something in my head.
Okay. Well, this is something we can do for next time, okay? Hi, Tim. Any questions? I see some people have got to go at 12:30, so it looks like we're wrapping up our time. Has everybody had a good time?
I'm seeing thumbs up.
Thumbs up. So we are doing this. We're going to keep repeating these things. So 2 weeks from now, we're going to pick up the cyber challenge again and keep going. So hopefully we got 2 weeks. We shall solve it, right? We'll solve the problem within 2 weeks, and then we'll do the more advanced challenges. And keep in mind, all this, it keeps building, and we'll be doing coding in Python and other things later on. So it's going to change the way it looks. It won't be just blocks. So stick with it. Should be really fun. Thank you, everyone, for coming. Anything else for the good of the order?
I don't think so. Not for me.
Awesome. Thank you, everyone.
Yeah, thanks all.
Be cool and have fun.
So
Bye.